It's good. We're able to start from now. Okay. Okay, in today's session, we'll start with understanding what is data modeling and why data modeling and the different types of relationship that are available in data model. And then we will move on with understanding the different types of different phases of the data model. Okay, as part of the design stage and requirement stage, what we do as part of the data model. Okay, that we will take a look at it now. And to start with, let us understand what is a data model and why data modeling is required. Data modeling, when it comes to Power BI desktop, yes, you need to do the data model design. Though Power BI tool can automatically detect the relationship between the table, still you need to go ahead and cross validate whether the relationship automatically detected and created by Power BI desktop is correct or not. Okay, first thing first, what is data model? Data model is the process of creating a representation of the structure and relationship of data in a system. As part of data modeling, what we do is we will define or identify all the tables or the entities that are relevant to your project or system, okay, as well as identify the attributes or the columns and the relationship between the tables. That is what we do it as part of the data model. First, what we do is we identify the tables that are required for your project also. 1 second, let me just. First of all, we will identify what are the tables that are required to create your report. Okay, once you identify the required number of tables or the tables, the next step is we will be finding out the number of or the columns that are required for each entities or tables. So in the case of data model, right, in the case of data model, we call tables as entities. Let's say you have a table called customer table. The tables are called as entities. And then the columns belongs to the table, columns, right? Columns are called as attributes. And then the relationship between a table to another table. For example, this is your fact table, sales fact table, and what relationship exists between the customer and the sales fact table. So at least one customer it would have raised an order, or for each customer you raise or at least for one customer you would have raised an invoice in the past or today. Okay, in that case, each customer can also have more than one transaction. So you would have purchased more than one time also. Okay, in the e-commerce system or in store, each instance of a customer, you can find it multiple multiple occurrence of the same customer. You can find it in this fact table. So relationship, right? So this is one-to-many relationship. Here, each customer name will appear only one time. The customer key is unique here. Okay. So in simple term, identify what are the tables that are required, and each table, what are the columns are required, and what relationship exists between the tables. That is what we do it as part of the data model. And in simple term, right? So the data model is something similar to your building architect's blueprint. So without having a blueprint, if you construct a house, what is going to happen? Without a blueprint, if you construct a house, later point in time, if you wanted to include some provisions in your house, what will happen? sometimes what will happen, it can lead to major rework, right? That's the reason why before you construct a house, you will have the blueprint. For example, you want to have, let's say this is what your living room. Okay, in a house, this is your living room. This is your living room, and this is what your kitchen, and this is your restroom, and you have master bedroom, and here you have the restroom. Okay, and so in the kitchen here, let's say this is your kitchen. Okay, in the kitchen, you right, so you did not keep two taps. You kept only one tap. At the time of construction, you did not take into account of the additional tap. Later point if you realize and if you want to keep it, especially if you are living in an apartment, what will happen? You will have to break the walls of your neighbors also, right, to keep a provision, to keep an additional provision for the tap, right? So it's a major rework. Again, you need to get approval, and you do not know whether your neighbors will accept or not, right? So those kind of issues will come up. So that is the reason why before we construct a house, we make sure that we have a blueprint in place. Once you have the blueprint, and next, if you construct the house, then you will not land up with any kind of major rework. Okay. Similarly, in the case of data model, if you take any application, before you build any application or any app, right, mobile app, whatever it may be, you need to have a solid data model design in place, without which if you develop your application later point if you think of making a changes to your data model, it will become a a major rework. Okay, just give me a second. We need to have a solid data model design in place. Okay, the data, that's the reason why we compare, most of them, they compare the data model with the architect's blueprint. Okay, as part of data model, what are we going to do? What task are we going to? In simple term, you identify the entities, attributes, and the relationship. Entities. Let me select some color. Why is that? No. Okay, entities, attributes, relationship. So what are entities? Entities are also called as the tables. And attributes are columns. Relationship is relationship. Okay. In the past, traditionally, right, conventionally, in the past, the olden days, they called tables as entities, columns as attributes. So as part of data model, we identify what are the tables that are required to create the reports. Like I said, you have the customer table, and you have the products table, category table, likewise different tables, and then you have the transaction table. The transaction table will capture each and every minute or every second, whatever the orders or the transaction that customers make it, that one will get stored in your table, order table or something like that. Okay. So that is what is getting registered here or recorded here. And the customer dimension, right? Customer and product dimension. They say you just sell only 20 products. In that case, every day, every minute, you don't have to insert the products. But if you look at the e-commerce websites, yes, they introduce new products. Take, for example, in the case of Amazon, they listed 1 billion products. Okay, but net the transaction files or tables like order table, it'll have more frequent in the transaction will happen here, all the data. So in this case, what happened, you identify all the tables that are required to create your reports, create the reports. Okay, let's say what we do is, in real world scenario, in the real time scenario, 1 second. Yeah, this is the color I preferred it. So let's say you're at offshore and someone at on-site. Okay, from on-site in your company, somebody is at on-site, in the sense they are working out of the client location. Client location. Let's say USA client. Okay, and from your company, let's say you work for Deloitte. right? So this is your offshore team, including you are sitting here, all report developers. This is your offshore, okay? And so from Deloitte, they would have sent 1% or 2% to the on-site, okay? And he's the lead, and he's the one interacting with the customers, understanding the requirement. And if it is a full-fledged project, right, in the sense end-to-end project, the software development life cycle, the first phase of the software development life cycle is the requirements phase. SDLC, software development life cycle. The first phase is a requirements phase. As part of this, the lead, okay, or the business analyst or technical, this lead is a kind of a techno-functional person. He knows the domain, business domain very well, as well as he's a technically strong guy. So he's the one interacting with the customers by conducting some workshop. For example, this guy is talking to a specific department, sales department. He's the one talking to a sales department, senior people or the stakeholders. And the sales department, what they do is they involve all the key stakeholders as part of this workshop, so that there should not be any loose ends. Okay. In the sense, if you talk to only few of these sales department people, and if you go ahead and create the table, hurry burry, what will happen? Again, if some other person, right, belong to sales team, which he get to know that you already spoke to the people, and when he comes back with his requirements, again you need to change your model. Hence, make sure that you involve all the key stakeholders that are available as part of the department, any department, in this case, sales department. The department, instead of saying department, we call them as a line of business. Each line of business, key stakeholders, so he's the one will conduct a workshop and understand what is their pain points, what are their exact requirements. Once he understands holistically from all the key stakeholders, and then he will come up with the conceptual data model. You have something called conceptual. As part of that, he will understand what are the tables that are required, what kind of business process that is happening. Customers, for example, it is a grocery store. So when you talk to them, that you understood customers, places, orders, they places different products. The customers places different products in different orders, or in the same order. It can also, they can have multiple products they can order it. In this case, while talking to them, you'll get to know what are the entities that are required. What are the entities that needs to be covered to create a data model designed for the sales department. Okay, customer table is required, product table is required, and then you have something called category table. Category table. Okay, and a single category can have more than one product also, right? A single category can have multiple products in it, and a single order can have more than one product in it, and each customer, right? So, or zero or more customers, they would have ordered the products. While talking to them, you will get to know the big picture as part of the requirements phase. Who? The lead. And then you will document everything, identify all the tables and the relationship, how the data flows between the tables, amongst the tables, you will understand, and then define the relationship. Relationship, something like this. A customer, zero or more customers, zero or more customers can order, zero or more orders. Or each customer, right? Each customer may order zero or more, they may raise zero or more orders. So not necessarily if you have 10 million customers, all the 10 million customers, all the time they have to raise an order, right? So some customers, they don't even order, or something like, at least one customer you would have ordered in the past. That is the reason why you have the customer name stored in this table. Okay. So one or more customers would have, or a single customer would have ordered multiple times the orders with your shop, and they would have ordered more than one product, one or more products. And these products falls under categories. A category can have, each category can have more than one products grouped under it. So these are the things. And again, right, they sell these products. The customer ordered the product through some store, right? They ordered the products via some store, and which store, which customer order what product, how many products they ordered, and which product falls under which category. So to answer to those kind of questions, you need to have these many number of entities and how these entities are interact with each other. What kind of relationship? Each customer would have ordered one or more orders, and they would have ordered, and each product would have been ordered one or multiple time, right? Say one or multiple time, and the category can have, each category can have one or more than one products in it. And each product by the customers would have ordered one or more time, one to many relationship. This is what relationship. So now you understood what is data model. Data model is a process of creating the structure and relationship of data in a system. So as part of the data modeling exercise, what we do is we'll identify the entities, which are nothing but the tables that are relevant to your reporting requirement or the system, as well as the attributes, which are nothing but the columns and the relationship between them. Okay, this is what called as your data modeling. Okay, at a high level. Okay, and so look here, this is what, let's say you are a grocery, you're running a grocery, let's say you are working with a grocery client. When you're talking to them, when you talk to them during the workshop with the sales department stakeholders, you get to know that customers orders products, each product falls under different categories. Fine. So and then you understand the relationship, okay, the flow of the data, everything, and then you document it. Okay, so these are the three types of data model. Okay, the conceptual data model, logical data model, and physical data model. What is a conceptual data model? It is on a high level. It gives you an abstract view of the entire database system. It gives you an abstract view of your entire database system. What do you mean by abstract? It gives you the gist of your entire database or bird's eye view of your entire system. Okay, at a high level, let's, you know, if you go above the sea level, 100 feet or 1000 feet above the sea level, you can see the entire city, right? Something like that. So you will get to know that, okay, these are the tables are required, fine. And kind of, you know, this is how the data are flowing between the tables, fine. Conceptual data model, okay. The whole idea of the conceptual data model is to capture the essential structure and scope of the data to represent it in a way that is easily understandable to both the technical as well as the non-technical stakeholders. Both the, you know, tech and non-tech stakeholders can understand with it just by looking at the, hey, and someone when they see it, anybody, right, even though they don't have any technical background, they can say, hey, you have the customer, you have the order transaction table, and you have store dimension table, category and product, everything is there. Where is the, you know, the country data? Country, you need to have a separate table. You need to, and by looking at it, they can suggest. This doesn't require too much of technical background. And right, so what they do is they identify the big picture. As part of the big picture, as part of the scope of the project, what entities that are required at a high level and how the data flows between them, they'll understand, identify, and then they document it. Once they document it, they'll share it with the stakeholders. Once they review the document, and if they find any gap here, they will, you know, they will send out their feedback. You need to accommodate that. Like I said, country table is missing. Can you please include? Yes, you can include it. And how the data flow from country table to other thing, you need to ask them. And then you revise the design. Once again, share it to them. Once they sign off saying that, hey, everything looks good, go ahead. Next step is you will get into the logical data model. Okay, it is an extension of your conceptual data model. In this case, what we do is, in addition to identifying the tables, we go one step further. Already we have identified the required tables at an high level, and each table, what are the columns are required. You are going to define the columns and the relationship in a very granular and that comprehensive manner. Okay, for example, you have the customer dimension tables, customer table. And here you will put customer ID. I just write it here because space issue. Customer ID, customer name, and then maybe his date of birth, and address, shipping address, address 1, address 2, and then area, and then pin code, and then status, active or inactive. So all the required columns at a granular level, you are going to define it. Okay, and then you will come up with the, and then you'll come up with the relationship. Okay, you define the relationship between the tables. Okay, not this one. Okay, the relationship between the table. This table is, the data is flowing this way to this table. Okay, to identify the relationship, whether one-to-many relationship, one-to-many, or many-to-one, or one-to-one relationship, or many-to-many relationship. These are the type of relationship you will define it as part of the logical data model. As part of the logical data model, you go one step further in identifying all the necessary columns that are required as part of each and every table. You will define it. Apart from that, you will identify the relationship. Like I said, a customer can, a customer, may order or may not order a product. 0, or a customer may order zero product, or he may order more than one product also. So here 0 to many, 1 to many, or 0 to many. Okay, 0 to many. And in this case, the products, this is your products table. So what kind of relationship you need to define it here between the order table and the product table here? This is your order table, and this is your products table. What kind of relationship? So 0 or more products can, so or not, we cannot say 0 or more, right? 1 or at least one product should be there in your order, or each product may appear in more than one invoices. Here, make sure that, the product table, customer table, these are called your dimension tables or lookup tables. Okay, and in the dimension tables, you must be having a unique key in it. For example, customer dimension, customer key, it's a unique value. It cannot have duplicate records, duplicate values in it. Similarly, product table, your product key, and similarly, country table, country key, and category table, category key. These key columns should have only the unique values in it. It not have duplicate values. Yes, Pavitra, you are absolutely correct. Very good that you are concentrating very well here. Okay, Pavitra and Sushmita and Divya, you are correct, right? So this is what the relationship is all about. Okay, you identify the columns at a granular level and the comprehensive level, right? You will identify, list out all the columns that requires as part of each and every tables, and then relationship you define it. It's a one to many, one to many, one to many, something like that. Okay, and once you are done the design, logical design, you will be sharing it with the stakeholders once again for their review. Once they review it, and if they find it everything is good, then they will give you a sign off. Each and every phase, at the end of each and every phase, make sure that you are getting a written sign off from the customer. Okay, once you got, let's say you got sign off from the customer, the logical data model design, whatever you did, and the next stage is the physical data model. As part of the physical data model, it's nothing but the actual implementation of the database system. So here already you identified all the columns and all the things, but here what it is, you go one step further. This is my customer table. Okay, in the customer table, we have already identified CID and CNAME and all, right? These are the columns, right? All the columns will be there, but here we define the data type for each column and then the width of the column. For example, varchar of 50. So the width, keep the width for the character, the customer name as 50, because some customer name will be too long, right? So 50, and customer ID, you can keep it as integer data. Here, you are going to define the data type in addition to the columns that you have identified in the previous stage. And then you define the width of the column. And the next thing is, you're right. So you are going to physicalize the tables. You are going to share this. Once you define the data types and the width for the columns, you document it in a design document, and then you share it with the customer again, and then you get sign off from them. And then only the DBA, a person called database administrator, a position called database administrator. So they are the one responsible for physicalizing all the tables, which means they are the one going to create all the tables in your databases. For this, In this case, we are talking about the sales department. All the sales department related tables will get created under a sales schema. Hope you understood what are the type of data model, right? What are the phases of the data model? Conceptual data model, logical data model, and then the physical data model. Can you see it here? Yes, here I mentioned the data type for each and every column. Okay, and product is integer, product description is a varchar of 50, and so on. Okay, and here we understand the big picture. As per the big picture, we come up with the entities or the tables that are required, and how these tables are interact with each other. At a high level, you will have an idea. And the next phase, logical data modeling. So you are going to define the attributes at the granular and comprehensive manner, and then you define the relationship here also, right? Can you see it here? This, this is the one. This is the one. The link. The link is nothing but the relationship. Okay. This is called crow's feet. Okay, crow's feet. And if you see one along with the crow feet, that means at least one date or time data should be there in the sales transaction table. In the case of product lookup table or the dimension table, 0 or more product would have been ordered. Okay, a single product or a multiple product would have ordered in each transaction also. Okay, so we need to define the relationship like this. If you see the entity relationship diagram, you will get to know how these. So if you are part of the development phase, like I said, what is the software development like? What are the phases are there? The requirement phase. Sorry. One is the requirement phase. The first phase of the software development life is requirement phase. Second one is the design phase. And third one is the cut phase, coding and unit testing. Okay. And fourth one is QA. And then the fifth one is UAT. And sixth one is production. The interview, they'll ask you which phase of the projects that you involved in the current project. You tell them cut, coding and unit testing. My responsibility is create a report and then test it. Unit testing, who is going to do? So I am the developer. I am the one supposed to do the unit testing. QA, we have a dedicated QA team. They will be doing the functionality testing with the reports, whatever we developed it. Okay, which phase of the, I have involved partially in design as well as cut phase, you can tell them. Requirement phase in general, people at onset, they do it. But there are some cases, the Americans, right? The customers themselves, I heard some guy. So he's the one gives you all the requirement, everything. You need to interact instead of interacting with various stakeholders of the customer. You can directly interact with this guy, as per the requirement phase, and then you get all the information and define the conceptual data model, logical data model, and then physical data model. Okay. So you can tell them that you are part of the cut phase, coding and unit testing. The next question is, why do I need to do data model? So is this how we do the data model design in other reporting tools also? Or is this specific to Power BI Desktop? Or the data model concept itself specific to Power BI? No, data model concept is not specific to Power BI. You take any analytical tool before you or analytical tool or any application, data model, we have to do it, or someone has to do it in your project as part of the requirements phase and design phase. They will be doing it. They identify all the tables, columns that belongs to each table and the relationship, everything. They are the one will take care of it. Okay, fine. But the data model is not, the concept specific to your Power BI. It is not specific to Power BI. It is part of your data warehousing or your business intelligence. Okay, or even in the case of OLTP applications, we do the data model design. This is not specific to Power BI, but when you compare other reporting tools like Tableau or ClickSense, yes, Pavitra, you're correct. Okay, so in that case, you don't have to do the data model design explicitly. It takes care of it automatically. But in the case of Power BI, though Power BI has the capability to automatically detect the relationship between the tables and create everything, but still, it is the responsibility of the Power BI developer or the lead to make sure that all the relationships are defined correctly. In case of any gap, they have to address it. Okay, the next question is, why do we need to do the data model design in Power BI? If you don't do the data model design, which means if you don't create the relationship between tables, it will not do the filtering correctly. So what do you mean by filtering? What do you mean by filtering? If you don't define the relationship between the tables, look here, we have two tables, right? These two tables are standalone. We did not create any link between the tables, right? So in that case, what will happen is your report will show wrong data. So in the x-axis, we have plotted the month name. The y-axis, we have plotted the sales amount column. But if you look at each and every month, the same sales amount got repeated. The height of this rectangle is similar across all the months. It is not doing the filtering correctly. In order to do the filtering, you need to create the relationship in the data model for the tables. Okay, that is what your data model design in a nutshell. Okay, for example, what is filtering? This is very important concept. Please understand it. Okay, concentrate. Filtering. What do you mean by filtering? This is my country dimension table. My table name is something like that. DIM country, customer dimension. And then this is my sales fact table. The transaction tables in general, in the case of business intelligence world, they call it a fact table. The dimension table, the lookup table, it is also called as a lookup table. Or customer country dimension in this case, sorry, country dimension. So we write it this way, DIM country in practice, but when we pronounce it, we will say country dimension. This is the naming standard most of the project or customers they follow, but there are some customer DIM underscore country, something like that will be. But when you see DIM along with the table name, that is nothing but country dimension tables. This is fact. If you see fact along with any table name, there's a transaction table, lookup table or transaction table. Okay. So usually we call we never say transaction table, we say fact table. And this is your lookup table. So what is filtering? We started with the filtering. Okay. What is filtering? This is my lookup table, right? So there is a requirement. I want to get the data from both the tables. I want to get the data from both the tables. How? I want to, in my report, I want to display the country name, and against each country, I want to display how many number of units we sold in each country, how much sales we made in each country. We wanted to generate a summary report. Since you need the country column from here and then the quantity sales column from this table, you need to query these two tables to get the three columns. In order to get the three columns, from these two tables, you need to join these two tables. Otherwise, you will not get the country name. So how do I join the table? Find out the common column between the tables. Country ID and country ID is common between these two tables. Country ID and country ID, both of them are common between these two tables. Okay, fine. What am I going to do next? So you need to create the relationship link, okay, between these two tables based on the common column. Supposing you don't have the country ID, then you cannot create the relationship. You cannot query both the tables data at a time. Okay, it's a painful process. Definitely, you must have a key column here and here. So here it is called as a primary key column. What do you mean by primary key column? The country ID is the primary key in this case, which means all the values in this column should be unique. For example, US, you cannot insert it again. Duplicate records. Duplicate IDs are not allowed here. That is what is called as the primary key. But here, the same country can occur more than one time, isn't it? Yeah, in US, they would have, they must be, in US, multiple customers would have purchased at different point in time. Hence, the country ID can get duplicated in the fact table, whereas in the dimension table, country ID should not have duplicates in it. Full stop. You understood? So now I'm going to discuss about the core of filtering. So once you create the relationship in Power BI Desktop, what will happen is the country dimension table will propagate the country ID to this table, because we have created the relationship between these two tables based on the country ID columns. Country ID columns is available in both the tables. That is the reason why we are able to create the relationship. Fine. So now the question is, why should I create a link between the common two tables? Only then, if you want this country dimension to filter this table, it is possible. In this case, what happens is it will propagate, or it will pass the first record's country ID value to this table. When it passes, this is a fancy term, they say propagate, which is nothing but passing or sending the value. We're sending the US country ID value to this table. And then what happens once this table comes here, it groups all the US related records. And then let's say you have used some function, okay? Sum on the quantity and sales. What will happen is it will give you only one record. So United States and quantity sales. Total quantity, how much? 2 plus 10, 16, 18, right? 18 quantities. And then sales, it will add all the value. And then it will give you only one record. This is called your summarization. Don't give me the transaction level. Give me the total units we sold, total sales we made in United States. Done. This is done. Okay. So it propagates the country ID value US from this table to this table. Upon receiving this value, US groups all the US related records, and it applies the aggregation or summarization on quantity and sales, right? Once it has been done, it automatically skips to the next record. Next record, what value you have in country AU. This time AU will be sent to this table. All the AU related records are grouped here. So this one and this one and this one. So AU, how many units we sold in total? 15 plus 2, 17. And then this value will get added. Once that has been done, it will come to the next record, GE. So GE, it will propagate the value GE. How many records are there for GE? 2 records. Similarly, it propagates, and then it goes to the fourth record. NZ is there. NZ will be sent here. And then all the NZ, New Zealand values will get grouped into a single row, and then it does the aggregation. Aggregation can be sum or average. It can be anything. Or you don't want to do any aggregation. Simply, you wanted to display in United States how many transactions. You display all the transactions. In this case, 4 transactions happened. Red color, right? You can see the red color. All the 4 records, you display it. Either you can do the summarization, or you can return the number of transactions that happened in each country. That is also possible once you define the relationship between the tables. It is as simple as that. This is called filtering. Obviously, when it sends the US column value to this table, it groups it filters only the US related records, and then it applies the sum on the quantity column, sum on the sales column. Remember this is very important concept, because even if you watch many videos in YouTube, others video, they'll keep on talking about filtering. This is what filtering is all about. In order to do the filtering, you need to have what? In order to do the filtering, what do you need? All of you, please type it in the chat window. Yes, Pavitra, you are correct. Who else? In order to do the filtering, you need what? Jamal, you are correct. Pavitra, you are correct. Susmita, you are correct. How about others? Why do we need to create the relationship between the tables? Why do we need to create the relationship? Because I wanted to query the data from both the tables in a single query. In order to query the data from more than one table using a single query, you need to have a common column between the two tables. Why? You need to join these two tables. To join a table, in this case, join the tables, you need to have the common column exist between the tables. Only then you can create the relationship between the tables. To create a relationship, what is required? Common column should be there in both the table. Please wake up. Hello. Okay. This is the common column. This is the common column. You need to link these two things. Only then you'll be able to do the filtering in Power BI Desktop. I'll just give you a demo here so that you'll be able to understand the importance of filtering. I'm loading a file, sales fact table or file. And then I'm going to the get data. Okay, 1 second. NC sales. I'm going to. So I'm loading the sales fact table. That's all, guys. Don't get confused with the naming convention and all. I'm loading a fact table now, sales fact table. It'll take some time. Now I'm going to rename it with some meaningful name. Sales fact. Next, I'm going to load another file. I don't know why it is not getting renamed. It's painful thing. The latest version, whenever they release the latest new version, this is the problem here. Calculate data. All right, so I'm going to expand the details pane here. Now, what happened here? Apply changes. Okay, NC sales. This is the table or file that I loaded it here, and I'm going to click on the get data and hit the Excel workbook connector, and I'm going to load the dim location. We have something called location dimension. Now we are going to take a look at what is the impact of not defining the relationship between the tables. Why data modeling? To justify that, I came here. I am giving the demo. Now I'm going to hit the load button. Next, I'm going to open the Power Query Editor because some cleaning needs to be done. Okay. Transform data. I'm going to click on the transform ribbon. And here, if I click on the sheet 1, which is nothing but my location dimension. And I'm okay, still it is loading it. At last it was done. And here I'm going to rename it as dim location. Okay, here I just go here and click on the drop down because the column names are not mentioned correctly. And I just promoted the first row as it is. Yes, we are done. And this one, I'm going to give some meaningful name. At least here it works fine. And I'm going to fact. So good. We have loaded both the files, sales fact and location dimension table. Two tables are available currently. And if I go to the model view, look here, we have the two files we loaded it. Files are called as the tables in Power BI. But importantly, if you notice here, the link between these two tables got created automatically. This is what the relationship. So if you see here, this is one side, this is star is many side. One to many relationship exists between. Because each location, you might have received more than one order also. One to many relationship exists. Okay, what is the next thing? What is the big deal now? Okay, it automatically detects the relationship between the tables. That is what the point you need to remember. Next one is I'm going to click on the clustered column chart. When you click on it once, it will get dropped in your report canvas automatically. Resize it, and then now what I do is in both the tables, I'm taking the columns. In the sales fact table, I'm going to drop the sales amount column here. In the location dimension table, I'm going to drop the location name here. The sales amount did not come here. Okay, I just redo it one more time. I'm going to increase the font size. Can you all see it now? I think it is pretty clear. So I have used two columns. One column was from my sales fact table. This column came from sales fact table. And this location name came from dim location. These two columns came from two different tables. Okay. So what happened? It did the filtering automatically. This one came from dim location. This one came from sales fact table. The dim location table filtered the sales fact table. You remember my PowerPoint? I explained you filtering, the red color one. dim location dimension table filtered the sales fact table automatically. Hence, we can see that in Chennai, how much sales we made in total, in Delhi, how much sales we made in total, each location, how much sales we have made, that breakdown was given because the location dimension table filtered my sales fact table. So, okay, now if I go to the model view, yes, Pavitra, you are able to understand. Pavitra, yeah, you are correct, Jamal. If I'm going to remove the relationship between these two tables, keep the cursor on top of this line. This is called link, delete. Right click on it, delete it. If I delete the relationship between these two tables, what is going to happen? It will not pass the value from here to here. Hence, it will not show the accurate value. When I click on that, can you see it? All the location, it shows the same sales. This is wrong. This is wrong, right? It is not doing the filtering because why it is not doing the filter? Why it is not doing the filter? Can someone type it in chat window? Sushmita, you are correct. Pavitra, you are correct. Jamal, you are correct. Raji, you are correct. Divya, you are correct. So why it is not filtering the table? Yes, Yamini, no relationship exists between these two tables. So I need to, how do I create the relationship? I just probably you can, select the location key column from dim location table and drop it on top of the location key column, which is our my sales fact table. Location key. You need to select the location key here and then drop it on top of the location key only, not on other columns. Now, if I go back here and see it, yes, all the rectangles are not at the same height. And we can see that very clearly. It did the filtering. The location dimension table was able to filter the sales fact table. Now we understood the necessity or the importance of creating the relationship between the tables, which is nothing but the data model. Without data model, it will not do the filtering. You will get something like this without relationship. Okay. Hence, make sure that is the reason why we need to design the data model. Next one is the process flow. As part of the data modeling, how do you go about it? So as part of the data modeling, like I said, the first phase of the data modeling is conceptual phase. In the conceptual data model, we will define the abstraction of the entire system, right? The tables that are required for the entire thing. Okay, all the tables we will identify that are required for my reporting requirement. Identify the key properties of each entity. And each table, you tell me which columns are unique. Customer dimension table, customer ID is the key column. Product dimension, product key is the key column. Identify the key column. Identify the relationship among the tables. Map the attributes to entities completely, and then visualize the data. Like I have visualized the data here, right? Visualize the data and assign keys as needed. If you think it is not displaying the value like the way how you expected, maybe you may have to assign the keys if anything missing it, right? And then finalize and vet it with your stakeholders. Once you are done with your design, everything, once you tested it by plotting the data into your Power BI desktop, also you can go back and share the outcome with the customers, get their sign off. Okay.